Hi everybody, this is Chapter 7, and in Chapter 7 we're going to talk about similarity, mainly with triangles, but we will look at polygons, other polygons with similarity. The first section that we're going to look at here is going to be 7.1, ratios and proportions, and we will look at how to write ratios and work with extended ratios and solve proportions as well. So a ratio is a quotient of two quantities. Fractions are ratios, but sometimes ratios can be written as in other notations. So you can use the word 2 between them, like here they have the ratio of 1 to 2, or you could write it as a fraction, or you can use a colon between the two. And they're all read the ratio of 1 to 2. A lot of times, excuse me, we use ratios when we are in the education field, talking about students to teachers, like the ratio of students to teachers is 5 to 1. School systems are big on promoting a low student to teacher ratio. Or you could say the number of students to pencils is, 10 to 12, or students to computer devices or electronic devices right now is big. So, they have a 1-to-1 ratio. Every student has an electronic device. One important thing to note when you write a ratio, you always want to, if you have the ratio written out in words, the first part of the sentence is always the first number in the ratio or the numerator. The second number is your denominator. So if I were to write the ratio of 12 to 17 using fractional notation, my 12 would go on the top and 17 would go on the bottom. And whenever you write a ratio, again, the first part of the sentence, or the part before the 2, is the first part of the ratio, the numerator, and the second part is the denominator. So here we're going to write each ratio as a fraction in simplest form. And one important thing to note about ratios is you always want to have them have the same units. So for the first one, we're talking about money. It's in the same units. So if I were to write this as a ratio, to start off, it would be $15 to $10. But they want it in simplest form. So we do want to simplify our ratio. And I can divide both of these by 5. So it becomes 3 to 2. So that would be my ratio in simplest form. Now for B, they didn't specify what units they wanted, but we have feet and we have inches. So we do need to convert to one or the other. It's up to you. Remember, there are 12 inches in a foot. So, I could make this 2 feet. So I could do 4 feet. And I just got that by taking the 24, dividing it by 12. So we have 2 to 4 feet. I can divide them both by 2. Now, the important thing here is when we're writing a ratio, you want to keep both numbers. So even though if I divide this by 2, and the bottom becomes a 1. Normally, like with a fraction, we don't put the 1 there, but with a ratio, you have to keep the 1. So my answer will be 2 feet to 1 foot. And again, you want to keep both numbers there. For C, we have centimeters and meters. I know that there are 100 centimeters in 1 meter. So if I convert, I could do meters. I could do 5 meters over 7 meters. And really, for that one, that's all we can do. We can't do any simplifying, so it's in simplest form. All right, so here we are going to find the ratio of this rectangle's width to its length. So the width is 5 feet to our length of 7 feet. Now, we could write it like that, or we could do 5 over 7 and put our feet there so we keep our units. Or we could write it as a colon. We could do 5 colon 7. Now, the next one, they want us to find the ratio of its length to its perimeter. So I know the length is 7 feet, but the perimeter I do need to find. And if you recall, it's a rectangle, so opposite sides are congruent. And perimeter, it's a good review. We add up all the sides. So 7 plus 5 is 12, and then 7 plus 5 is 12, so it's going to be 24 feet. So 7 to 24 feet, or you could put it as a fraction or write it as the colon. Any way would work. All right, next we're going to look at extended ratios. And extended ratios compare 3 or more numbers. So instead of just having 2 numbers in our ratio, we're going to have 3 or more. So typically we use the colon to describe these, or the word 2, not necessarily fraction form because it's way too long and it wouldn't look right as a fraction. But this can help us provide information about triangles. It can also, we see extended ratios used a lot, like if you see recipes, sometimes if they just want to, like I see this a lot for recipes for, like mixing up different colors in paint. And they will write the recipe or the information for it and say it's like 3 parts blue to 5 parts black to 6 parts red. And they won't tell you like gallons or ounces because people, when they go to the store, they can order they can get a gallon of paint, a quart of paint, just a sample of it. So, a couple ounces. So, if they write the ratio like that, you can convert it to gallons or ounces or quarts. So it's really kind of cool. All right. So here is our first ratio, extended ratio, and they are talking about the lengths of the sides of a triangle are in an extended ratio of 3 to 5 to 6. The perimeter of the triangle is 98 units. What is the length of each side? So to write this ratio, what you're going to do is, or to find x and then find the length of each side, you're going to take each part of your extended ratio, your 3 to 5 to 6, and you're going to write it with an x. So we're going to do 3x. In perimeter we add, so 3x plus 5x plus 6x. It's going to be equal to 98 units. We'll combine our like terms, so 3 plus 5 is 8. 8 plus 6 is 14, so we have 14x equals 98. We'll divide by 14, and we get x equals 7. So now what we're going to do is we'll plug in our x for each value. So we'll do 3 times 7, and we get 21. 5 times 7 will give us 35. And 6 times 7 will give us 42. And those will be the 3 side lengths of our triangle. All right, so here we're going to look at another extended ratio problem. And this time, we have the salaries of a secretary, a salesperson, and a vice president for a retail sales company, and they are in the ratio of 2 to 3 to 5, and their combined annual salaries is the amount of $124,500. We want to know the annual salary of each. So again, make it into an equation. X is going to be what is I guess, kind of think of it like the base salary. And then the secretary's is 2 times the base salary. The salesperson is 3 times the base salary. And the vice president is 5 times the base salary. So to set up our equation, we are going to do 2x plus 3x plus 5x equals 124,500. If I combine like terms, I end up with 10x equals 124,500. Divide by 10. So x is going to be 12,450. And again, that's your base salary. So to find the secretary, we would do 2 times the 12,450, and we end up with 24,900. That's the secretary's salary. The salesperson would be 3 times 12,450, and that is going to be 37,350. And then lastly, the vice president will be 5 times 12,450, and that is going to be 62,250 for his or her salary. So our next extended ratio practice is the measures of the angles of a quadrilateral are in a ratio of 2 to 3 to 4 to 6, and they want us to find the measure of each angle. Now remember, we're talking the measures of a quadrilateral, so each angle, or all 4 angles in a quadrilateral, always add to 360. So when I write my equation, I'm going to do 2x plus 3x plus 4x plus 6x equals 360, or 360 degrees. And then when I combine like terms, 2 plus 3 is 5, 4 plus 6 is 10, so it'll be 15x is equal to 360. When you divide 360 by 15, we are going to end up with x is equal to 24. So now we got to find the measure of each angle. So again, we'll do 2 times 24 for my 2x, and that'll be 48 degrees for the smallest angle. 3 times 24 for our next smallest angle is going to be 72 degrees. Then we'll do 4 times 24, and that should be, I think it's 96. Let me double check. Yep, 96 degrees. And then 6 times 24 is going to be 144 degrees. So those are the 4 angle measures for the quadrilateral. Okay, so here, the measures of 2 complementary angles are in the ratio of 4 to 5. Find the measure of each angle. So remember, complementary angles add up to 90 degrees. So we're going to do 4x plus 5x equals 90. We'll end up with 9x equals 90. Divide by 9, and x is going to be 10. So that means if we do 4 times 10, we'll have a 40-degree angle. And then 5 times 10 will be a 50-degree angle for our 2 complementary angles. Right, so the last thing that we're going to look at in this section is solving proportions. We're just going to review it. And again, a proportion is an equation that states that 2 ratios are equal. You want to find the first and the last numbers in the proportions, or they are called, the first and the last are called your extremes right here, and then your means are the middle 2 numbers. You can see it better here. It doesn't really matter if you know what the means and extremes are. The main thing to know is when we solve a proportion, we're going to do the cross products. So we're going to cross multiply. So I would multiply like 2 times 6 or 3 times 4. And that's kind of what's important to remember. If you ever get a question where it asks you, is this a true proportion, where they give you 4 numbers, so 2 full ratios, and they ask you, again, you cross multiply. So you multiply your extremes by your means. And if both sides, when you multiply, are equal to each other, then the proportion is true. So the last thing that we're going to do is we're going to solve 2 proportions in this section. Again, to solve a proportion for x, we are going to start off, we're going to cross multiply. So I just kind of draw my x, connect my numbers. Now, the main thing to remember here is you can't get rid of the equal sign. But 6 times 4 is 24, so that'll go on the right, and then 5 times x will be 5x. And then to find out what x is, we'll divide by 5. Now, I like this one because it doesn't go in evenly, and that's okay. X can equal a fraction. I wouldn't even turn this into a decimal. as long as it is a fraction in simplest form, you can leave it as a fraction. You don't even have to make it a mixed number. So we can say x is equal to 24 divided by 5. Now let's look at b. We're going to solve for y. So when I cross multiply here, I'm going to do 3 times y plus 4. And I'm going to write that out because you do want to distribute the 3 to everything in the y plus 4. And then y times 9 will be 9y. So now I have 9y is equal to 3y plus 12. We'll subtract 3y from both sides. So I have 6y is equal to 12. We'll divide by 6. So y, in this case, is going to be 2. And that is it for this section. In 7.2, we'll work with more solving of proportions and problem solving with them.